Hello. Yes, we welcome you back to PSSB, Physical Sciences Silver Bullet. It's me, Richard, once again. Um, Today we are looking at this question. Um, it is set purposely to get us familiarized with free body and force diagram. As we proceed along the way, we are going to find out that mechanics is too much dependent on this aspect. Um, Topics of mechanics are around four. They are all relying on the aspect of knowing free body diagram and force diagram. So how do you go about 12.1? It says a free body diagram of a box resting on the horizontal table. So what do we have here? We're going to assume this is our table. Okay. And we are representing what? Free body diagram. So our body comes as a dot. And from there, we explore the forces which are acting on our body, on our book. The first one is the obvious one, which is gravitational force acting vertically downwards. Then the second one is the one which is exerted by the surface of the table, which is the normal force. So this pair of forces is what we have, which is acting on our book. Okay. Then comes the next question. It says, a box resting on inclined plane. So in this case, suppose we have this one as our inclined plane. And what do we have here? This is our body. We said it's resting. Now you have to remember that if it is resting on the inclined surface, one of the force which is obvious is this one, which is Fg acting vertically downwards. Then another one is our Fn. You have to know that Fn must meet the surface at 90. So explains that curving. Then other part will depend whether the surface is rough or smooth. So if it's rough, then we are going to have our friction force that side. Because there is, on this incline, there is a tendency of this body or box to slide downwards. So our friction force is upwards. Our assumption is that the angle of inclination is alpha. So this is what we have. Okay, let's go to the next question. So there comes the next question. It says free body diagram of the car moving up the inclined rough surface. So our assumption is that if this is the inclined surface, the inclination is at angle alpha, and this is our car, and it's moving upwards. So what do we have here? We are anticipating that it's moving upwards by the virtue of the engine. So this is the force applied by the engine. Then what else do we know? We know that this car is sitting, there's an obvious force which is acting down, vertically downwards, which is the gravitational force. And because of it sitting on the surface, there's a normal force there. Remember, it must meet the surface at 90. Okay. then we say the surface is rough, so we have our friction force there. So these are the forces which are acting on that car. So let us look at the next question. So comes the next question. It says free body diagram of a car moving down the rough inclined surface under influence of engine. Okay, we brought in the influence of engine because a car can be moving down while coasting. Coasting means engine off, just moving under the influence of gravity. So when we put in the engine, it means that we are putting applied force. And what do we have here? The same scenario. We have our incline, and the car is moving where? Down. And we said there is applied force. So what other forces do we know? It's rough, so which means that there is friction force up there. What else do we know? There is Fg going vertically downwards. What else do we know? There is normal force. Remember, it must meet the surface at 90. So that is the scenario we are having. Okay, so let us look at more cases here. So then comes the next question here. It says free body diagram of a car coasting down on a smooth inclined surface. So you have the surface. Okay. And what do we have? We have our car. So what forces do we know which are acting on the car? First of all, coasting means there is no applied force. So we have our Fg, traditionally is there. We have our normal force. Okay, we said it is smooth, so there's no friction force. And we say it's coasting, there's no applied force. So for this case, these are the only forces we are having on that car. Then comes this question, a car colliding with the wall. So what do we see? We are having the wall and our car is colliding with it. So what are the forces which are acting on the car? The first one is the one exerted by the wall. Okay. Next, the car is sitting on the ground, so it has normal force. And there's traditionally gravitational force acting down, vertically down. So those are the forces we have which are acting on the car. For that, we can take away the wall and our diagram becomes clear. Okay. So comes this question, says a block hanging attached to weightless inextensible string. So what are the forces acting here? So you have your block, it's hanging. Hanging means that it's not sitting on the ground. So what does that mean? It doesn't have normal force, but it has our traditional Fg. Okay, what other forces are acting here? We have the string which is attached to it, and the string, the force in the string is tension, so it is tension which we are having here. Okay, Then comes this question. They want us to draw a free body diagram showing all forces on the ball projected upwards in a vacuum. Okay. What does the vacuum come with? Vacuum takes away the effect due to air friction. So that implies that you have your body, but the only force which is acting on it is gravitational force. Okay. Then comes next. Okay. Then lastly, we'll have this one. What do we need? A free body diagram showing all forces on a ball which is projected downwards in the vacuum. Like I said before, vacuum implies that there's no air friction. So what do we have? The same as before. We're having our ball and the only force acting is gravitational force. So what is the conclusion which can be drawn between these two? That if you ignore air due to friction force, whether the ball is projected upwards or downwards, there is only one force acting on it, and that is gravitational force. With that, would like to thank you for your time. The channel is PSSB, Physical Sciences Silver Bullet, and it's me, Richard. See you next time. Don't forget to subscribe. Bye-bye.